So today we've had a day off. Okay, I can't do 12 days straight. It's pretty intense. But I did have a really good call with Yesko from Acoustics Insider about my new studio build, and I thought it'd be great to show you that. Now, I'm going to leave this with the caveat that some of this just has a screen share for a lot of the recording, but there's a lot of good information, a lot of good advice he gives. There's a bit of context which you miss out on, but what I'm going to do is, because of that, next Saturday, so Saturday week, in 2 weeks' time, when I'm back in Melbourne, I'm going to follow his advice with the tests and make a video on that and actually run the tests, put them up against my measurements, see what correlates, assess what we've discussed, and then we'll get some findings from it, which I think is going to be really interesting. So for now, I'll leave you with that call and let's get into this. I've just had an incredible call with Yesko from Acoustics Insider. Even though I got up probably 10 minutes before this call, absolutely dead and groggy. He's been incredible at offering me some advice. So we're going to roll the clip. And thank you so much for Yesko for coming on. It's been a real pleasure having you sort of
You're very welcome.
really go into the weeds with this.
I'm very glad. You're very welcome. And I'm looking forward to seeing the final result.
Yes, well, I'm going to document everything.
Okay, excellent. Looking forward to it. Yeah.
Thank
It's going to
you.
be a
Thank you.
great sounding room. That's for sure. It's going to look great and it's going to sound pretty good too. That's for sure.
Awesome. Awesome. Well, let's jump into it.
Let's go.
Yeah. So as I said, there's like a lot of people with suggestions for the design, and
Hmm.
I've got my own thoughts on how I want to change it. But
Hmm.
yeah, I'm just curious to get another perspective. And I know you've got a pretty big voice in on YouTube with your stuff and documenting your work. So it's always nice to have that open critique and open book for
Sure. Yeah.
it.
I mean, mainly because obviously my thing is like a teaching thing, right? So
Yeah.
I don't really do designs myself. I teach people how to do their own, you know? And so
Yeah.
obviously I've through that I've seen the broad spectrum of approaches, problems, what's the word? Um, just the kind of the reach, how far you want to go with the thing, you know? And one of the most important things I've seen is just getting a grasp of what you can kind of expect with what you're planning to do, right? And so that's
Mm.
kind of what I wanted to get kind of feedback to you before we do anything else, just so you have a better idea of what you can expect, both in terms of acoustical performance, technical complexity, just construction complexity, all this stuff, right? And
Mm.
where the kind of the pitfalls will be with the design that you're aiming at right now.
Hmm.
And then kind of depending on what your experience level is, figuring out whether that's actually the route you want to go.
Okay.
Yeah. Yeah. So
Yep.
that's kind of, I just wanted to kind of take a step back and just say, I look at the broad picture and kind of go, okay, here's what's probably going to happen with what you're planning right now.
Okay.
Right.
No, I'm open to the critique. So I'm happy and healthy for it to be open book. And yeah, I think it's a journey, and I'm happy with whatever you have to say, because it's
All
all
right.
learning. And whether I don't think it's a thing where it becomes whether I agree or disagree. It becomes um, what input do I take on board, and what input do I consider, and then also what input is, how do I put it? Maybe I don't acknowledge. I go, oh, well, he said this, but maybe this works for me because of X, Y, Z.
Sure.
And I think that's the healthiest way to do it because, yeah,
Absolutely. I mean, the other thing is obviously everybody has their own everybody has to decide for themselves how
yeah,
far to take this journey, how
yeah,
deep to go down the rabbit hole. Yeah.
yeah,
And I'm totally I'm not going to critique anything, by the way. Yeah, if you don't get me
yeah,
wrong. My plan isn't to rip your plan apart. My plan is to show you what your plan is currently probably going to give you. Yeah,
yeah,
and
yeah,
talk through some of the details and kind of say look at what's going to be tricky, what's going to be easy,
yeah,
that sort of thing. Yeah.
yeah, of course.
Um, what else? There was something else I wanted to say. Can't remember by now. Well, let's shall we dig in?
Yeah, let's dig in.
But let's start with just the ground, kind of the groundwork, also just for me to understand what your level of experience is. Because obviously,
Yep.
depending on your level of experience with previous rooms, I might say, well, to be honest, then go ahead. You're probably
Yeah.
well prepared for all of this. So, do you want to just give me a quick rundown of what your previous experience has been with building studios,
Yep.
doing acoustics? How would you rate yourself in terms of kind of knowledge, not just knowledge, but also kind of skill level with the engineering side of things, looking at maths, looking at understanding some of the physics, that sort of stuff.
Yeah. Okay. So my last room I built was 11, 12 years ago. Like it's a long time ago, 2013, the end of 2013, I started building my last room. In terms of skill level, in terms of actual carpentry and building, anything you give me, I can build. Like as
Okay,
in,
cool.
so the last room I put up the whole frame, joists. I hang the ceiling and suspended the actual slanted ceiling and welded the S brackets onto flat steel. So anything
Okay.
construction wise is
You're
doable.
fit.
Even the diffuser you see in that design, I've already
Yeah.
built. I've
Okay.
already
Okay,
built
that's good.
that big diffuser is because that was a big job. But
Yeah.
that was done. So that's in the construction. The plan for my last one was based off the studio I was assisting at, whereby lots of broadband absorption, no parallel surfaces, which uh, isn't something I really understood at the time, other than it helps prevent flutter echo, but it's not something I'm going for in the new room for a particular reason.
Good.
And I had drywall on the back wall of the studio of my current one with nothing in it. And I saw that as an advantage because I'm not recording and I don't mind bass leaving the room so it doesn't build up. And the response in that room is actually very good given my knowledge at the time. So there were a lot of flukes that happened. Now my knowledge is with acoustics is probably too much. And the original design, which I didn't send you, was way more over engineered than this current one. And I realized there was a point of diminishing return with the effort. So I tried to just go back to fundamentals to go, okay, what has to happen in this space? What is going to get me the most amount of effect for the least amount of effort? Not to say that it's a lazy design, but it's a design where I want to maximize efficiency.
Simplified. Yeah.
Yep.
Keep it
And that's
simple,
where
stupid. Hmm.
yep. And that's where I've landed at now.
Okay.
The current trajectory.
Okay, cool. Well, that sounds great because to be honest, you're probably way ahead of the curve in many ways with all that experience already. And so that gives me a much better feeling because
Okay.
I've like some of my clients have done rooms like this, also Atmos rooms, and I know just how much of a struggle it was in many cases. Yeah, and so that's why
What was the struggle on specifically? The
just
resolve or the construction
the
or
devil is in the details, because you're trying to basically do an acoustic treatment along with a Dolby Atmos setup, and the technical challenge. Both have their own technical challenges that only kind of crop up when you start actually doing it, right?
yeah,
And yeah, and then so there are just a lot of little stumbling blocks that you keep having to push through, and
yeah,
that's what made it difficult. And then obviously cost is a big question because it's so easy to underestimate just how expensive it can get. Um, cost both from a materials perspective, and then also just from a time perspective, how much time it
yeah,
takes. Yeah. Obviously, with the experience that you've got, you'll be able to judge that already,
yeah, yeah,
how much time it will take. So that's an important factor, and it'll also give you a much better idea of the cost involved, which is also a big win. Yeah.
yeah.
By the way, might as well ask what budget are you planning? Just like overall, all in, everything included, where are you kind of setting your budget?
I've budget wise, I reckon we're talking Australian dollars because I know the materials. I've already had it estimated. I think without the flooring, because I want to redo the flooring.
Hmm.
I want to put all nice hardwood floor down. Um, without the flooring, I think we're at about 6,000 thereabouts, roughly.
6,000.
Yeah.
What's the short? What's the acronym for Canadian? Sorry, for Australian dollars?
AUD. So about 4,000, 3,500 US.
This is just for the acoustic treatment, though.
Yes, correct, correct. That's not
Okay.
including the flooring and fixing like skirting and other cleaned up bits.
And none of
Because
the speaker stuff.
none of the speaker stuff. No. Oh,
Okay.
the cables I can buy a spool of Megami for like 300-400 bucks
Hmm.
and terminate it all myself and solder it all myself. So if I have to do any cabling, that's very cheap.
Okay. And just out of curiosity, what speakers are you going for? What brand? What kind of system?
At the moment, I got the Neumann KH310A
Okay.
at the moment. And I kept them because I was going to buy new speakers a few years ago, but everybody who knew I was going into a new room said, wait till you're in the new room, judge the room with speakers you know, so you're comfortable with them, and then make a decision to test other speakers.
Hmm.
So I, so that's sort of where I'm at with them. So
Okay. But even for all the other
the
components of
Atmos,
the system, yeah.
I don't know yet. I'm going to pre-wire and then I'll decide to put something in. I'll pre-wire and then putting something in will be a decision I make after the fact.
Okay. I'm not I'm not like fully in Atmos systems because I don't deal with them regularly. But you're sure that should work as in terms of how different speakers are hooked up? Because I know, for example, Genelec, they're gonna be they would basically do all digital, as far as I understand.
Yeah,
Um,
that's not a
all
stress.
that's
That's yeah, none of that
all that you've got
pre-wire.
covered.
Yeah,
Yeah.
that I've
Okay.
got all covered in case. So I'll be running uh both passive and power to each point. So everything will have behind the wall, whether I want to run a passive system back to an amp, whether I want to run active, or if I want to go digital, I can pre-wire Cat 6 in there. It's fine.
Okay. 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 Good. So next thing. Well, first of all, no, well, next thing to check, I would say, is obviously I think, and I think you had that in your plan, was just the layout of the speakers that will actually work
Yep.
to Atmos standards
Yep.
within the space that you.
Yep. That's already been checked out with the Excel spreadsheet.
Okay. Um,
I'm pretty sure it has. Let me go back to. I sent you the Notion document, didn't I? I think.
yeah, exactly. So that's all the links with the same doc, I believe, weren't they? Let me just
Yeah, let
actually
me check.
let me just share that actually myself
Oh,
so we can
that's
have a look at it together. What is this? Yes, go for it. So this was the installation material stuff. So this is just you were just checking out different products, I guess, right? This is just a
yeah,
list of
yeah,
products.
yeah. I found a database of testing for things that were available in Australia, so that was good.
Okay. Is this still, because you said that this was your preliminary design from 2000, is this still roughly up to date?
The Dolby Atmos positioning is, the material research is, the assessment of the room acoustics is, um, yeah, the most up the current working one is that SketchUp file I sent you directly.
Okay, in terms of the actual treatment where it goes. Yeah.
Yeah. I think
Okay. This is
so that's just a rough layout, but like that was a
yeah,
preliminary layout, very roughly. That's not how it's ended up though.
exactly, because you don't have these bits, for example, right? If I see that correctly.
No. Correct, correct.
Yeah, yeah. Okay. All right. Well, okay. So, a couple of things then to consider or moving forward. Next things. What are the outside walls going to be? Or,
The
I mean,
wall,
it exists already, doesn't it?
yeah, it already exists. They're drywall and they've got inside them, inside the drywall, there's insulation that has a gas flow resistivity of about 8,000.
Okay. Um, And it's single layer drywall all around.
Single layer, yeah, correct.
Okay, so you're counting on the base escaping as well in this particular room.
Correct, yes, yes, yes.
Okay. Okay. Have you actually done any tests in the room yet? Because I mean, you made a video in it, right? It's the same
I
room.
made a video. Yep, I haven't made any tests yet in the
Okay.
room.
Okay. Okay. So, so one of the things that I'd definitely recommend that you double check, for example, so this was the first potential pitfall, right? You might actually find that the base doesn't escape nearly as well as you'd hope. Yeah.
Okay. Yep.
So that's something that is worth checking. Yeah.
Yep.
Just to get a ballpark idea of how strong rumors are actually excited in this space. Yeah.
Yep. Yep.
So one thing you could obviously do is put a speaker in a corner, put a microphone in an opposite corner, do a room EQ wizard measurement, and just kind of see which room modes pop up. Right, by putting the speaker
Yep.
in the corner, you should excite most, if not all, of the potential room modes, and then you can actually see on the opposite side if you measure on the opposite side whether the microphone picks them all up, how strong they are, and also whether they coincide with your room mode calculations.
Yep. That was something I'm very interested to know. So yeah.
Yeah. So that would be a first step, and the goal here is twofold. One, confirm the frequencies that room modes are actually happening at. Yeah.
Yep.
And second, how strong are they?
Okay. Could I ask a question? Why
Sure.
would it be, and this is my ignorance showing, why would it be corner to corner and not across the axes? So going down the length and down the width.
Because so room modes always have high pressure points in corners, right? And the tri
Okay.
corner is the
Yep.
place where usually all potential room modes um, have pressure maximums.
Okay. Okay.
Yeah. And
Yep.
so, what was the size of yours roughly? Do you remember off the top of your head, or it's in there somewhere, isn't it?
I think it's 52 by 3560.
5,200. No, it's. Could you just read it out for me?
Uh,
62,
no, no, 356
35. Yep.
and 270.
70. All right. Might as well get the actual numbers in. Um, so this plot here shows us where pressure maximums are, right? The colors don't
Yeah.
actually mean anything. Yeah, they are basically just the polarity of that
Okay.
standard wave, right? So
Yep.
if the blue kind of is below zero, the red is above zero, sort of. Yeah.
Okay. Oh, that's
So
better to understand. Yeah.
so you don't actually need to worry too much about what the colors mean, but let me just turn this off. Yeah. So if you look at any given corner, let's just take this top one here for argument's
Yep.
sake. Yeah. There should be a block in that corner for pretty much every room mode, even the really funky ones up here. Yeah.
Yep. Yep.
And so basically, if you put a speaker in a corner, you'll be able to put energy into all of these room modes.
Okay.
And then that way
I
they will actually
understand.
all pop up. Yeah.
That makes
Because
better sense.
yeah, if you put a speaker, let's take this one. Well, that's not a good example. Let's take, where is it? This one here. Yeah. If you put a speaker like on the long axis, for example, in the middle of the room, it won't be able
Yep.
to excite this particular frequency.
Okay. That's very
Yeah.
smart. All right.
Yeah.
All right.
So that's the first thing that you'd probably want to check. Yeah. And I think the main goal here would be actually to understand whether um, as much energy is leaving the room as you'd hope. Yeah, because obviously that would mean that if you actually put your microphone on the opposite side, that you're not getting much room mode action in the actual
Hmm.
measurement. That
Yep.
would be ideal. Yeah.
Yep. That would be good.
Yeah. Chances are that's not going to happen. I'm going to tell you right now.
Yeah. No, 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 no. I know chances are that's not going to happen, but it'll be good. I'm I picked these dimensions for a particular reason because I was
Okay.
limited by the ceiling height. Because
Sure.
the ceiling height of a residential build, you can either have a low, medium, or a high. And we got
Okay.
2.7 meter ceiling.
Hmm.
So that was always a fixed value. So I could play with the length and the width with the drafts person, and that's exactly what I did. So I
Okay.
did play with the length and the width, so that way I could have the speakers firing down the long axis. I could have the width, and I put them into room mode calculators to make sure, especially in the low end below like 100 hertz, I don't have two axes that are building up really closely to one another. That's why I've picked these particular dimensions. I didn't go by ratio. I
Hmm.
went by plugging in numbers that
Hmm.
worked with the actual overall build and then refining it to get this spot on.
Okay. So you did a decent job.
Mm.
Unfortunately, it could have been better. Yeah, it's not the end of the
Yep,
world. Let me just show you what the issue here is. It's not. It's one. It's one of many small things. It's not going to be a deal breaker, but it's just one of
yep,
the issues with this, right? So, what you basically want to do, ideally, is get a
yep,
consistent increase of room modes as you go up in third octaves.
yep,
Yeah.
yep, yep.
And so at the moment, you've got a hole right here.
Yes, I know. I know.
Yeah.
I did realize that.
Yeah. So this is between 33 and what is the other one here? 47 and 48 hertz. Yeah.
Yep.
What will happen if the room actually gets excited in the low end? Yeah. Which ideally shouldn't happen with the drywall. But if it does, what will happen is that in the untreated version of the room, you will actually see a lack of energy in the low end in this frequency range. Yeah.
Okay.
Because the idea is to get kind of room mode support at all uh, what is it? I just used the word at all thirds, basically at all. What do you call them?
Yep. Octaves.
Not octaves. A third of an octave is a
Perfect. Oh, you're testing my music theory now. A
yeah.
third of an
Anyway,
octave is
but you know
four
what I mean. So this is
semitones. Yeah, I think it's like a
split up into
perfect
third
fourth.
octaves.
Yeah,
Yeah.
yeah,
So basically, every third octave wants some room modes to have that support.
yeah,
Yeah, that's the idea with this whole
yep,
ratio game. Yeah,
yep.
and so at the moment, if the room builds up room modes, yeah, you will potentially see a dip in this frequency range here. What is this like
Okay,
30 something, 35 to 45 hertz or something? Yeah.
okay, that's interesting. Yeah.
Yeah, not the end of the world.
No.
But and you got this lowest room mode here to give you some support at the bottom end. Yeah, so it's not going to drop off like crazy. That's also happens sometimes. Yeah, so that's definitely
Yeah.
not going to happen. Yeah.
Yep.
That being said, we have to try and compensate for this potential lack of energy here. Yeah. One thing
Hmm.
is making the room leaky, like you did.
Yep.
Okay? Another thing that we want to do is optimize our listening position in this space. I
Yep.
sometimes call this the low end sweet spot. Yeah. And that's the spot in the room where the energy in all these room modes roughly balances out.
And how does that affect that whole?
It won't. You
Okay,
won't
good.
get
Yeah, yeah, yeah. I
that
thought you were
hole.
correlating the two. That's why I was
Yeah.
asking.
Well, it gives you the best balance outside of the hole, basically, right?
Okay.
Because
Yep.
if you, let's say, find a bad spot that accentuates this particular room mode, but puts you in a spot where this one doesn't give you much energy, you'll
Hmm.
actually see a steep drop off because of the hole right below this kind of 48 hertz thing, because that one is really boosted, and then you get a
Yeah.
really strong drop, and then you don't get anything catching that energy if you're going even further down in frequency. Yeah.
Okay.
So you
Yep.
still want to balance the room modes even outside of the hole, or better said, irrespective of this potential hole, you still want to try and balance out your room modes.
Okay.
Yeah.
Okay. In the
Yeah.
playback position. Yeah.
Yeah.
Or
In the
listening
listening
position.
position.
Yeah. Yeah.
Yeah.
Correct.
And so that's something you also want to do as a starting test. Yeah,
Okay.
because at the moment how did you position your listening position at this point? Kind of what guidelines did you
Sh-
follow, if
I
any?
think it's no, I did. I think there were two options. One, I can't remember. And then another one was like 3.8 or 3.75 or 0.375 of the room.
Yeah,
I think
gotcha.
it's on the
That's the
document.
38% guideline thing.
Yeah,
Gotcha.
I think it's and then there was another one where I split up the room into to fifths or thirds and then created an equilateral triangle out of it. Um, but I
Okay.
can't remember which one I went through on the preliminary assessment. That's why I document everything so I don't forget.
Okay. Um, that's fine. And to be honest, without doing a more analytical approach, that's probably as good as it gets. Yeah. But I
Yeah,
would recommend that you do some analysis of the low end pattern in order to actually confirm that that's where your low end sounds the best and where your listening position should go. Yeah.
yeah, yeah.
And so that's another thing that you can do with the speaker in the corner because
Okay.
once again, you're exciting all the room modes
Yep.
maximally. So you're
Yep.
creating this worst case scenario.
Yep.
And then you can actually just get in your chair and just roll on that center axis, basically
Mm.
front to back. Yeah, get an idea with playing while playing some music to get a subjective impression of where the low end sounds the most balanced.
Okay.
Yeah, in
That's
my experience,
interesting.
that actually works just as reliable as taking measurements. Yeah, in many ways, it's actually easier because it's hard to understand measurements, and you're very good at discerning what you're hearing. Yeah,
Yeah.
and people usually get within a couple of centimeters of where the ideal spot is just by using their ears and doing this procedure. Yeah,
Okay.
so that's another thing that you want to check in this preliminary test in the room. All right,
hmm
because obviously that will then impact potentially where the speakers go in relation to that spot. Yeah, how much space you actually have to the front wall, and you may have to actually adjust the position of all the Atmos speakers in the layout. Yeah, because
Yeah.
obviously if you're listening position forward by 30, 40 centimeters, the
hmm
entire structure changes. Yeah.
Yeah.
Yeah. So this is why it's so important to actually get the listening position right first, because everything else that you plan depends on that position.
Yeah. Yeah. Where I
Yeah.
run all my cables, everything. Yeah. Definitely.
Exactly. Yeah. Not
Yep.
just acoustically, but also just construction wise. Yeah.
Okay.
Exactly.
Those are good fundamentals to follow. Yeah.
Yeah.
Very good
Um,
fundamentals.
I'll send you. I've got a PDF that people sign up to on my website. I'll just send that to you. Yeah, and it's basically a step-by-step guide to this procedure. Yeah, so it'll just give you a bit
Yeah.
more. I would also recommend at that point to actually do a stereo system test. Yeah,
Yep.
um, just because you want to confirm that at that listening position with the speakers then set up in their actual stereo positions, you're getting a low end that you like. Yeah, the low end does change because when you move the speakers up out of the corner, the
Yep.
um, the low end, the room modes get excited differently.
Yep.
Yeah,
Yep.
but you're still in the position, but you're still in the spot where you can potentially get the best balance. Yeah, and that's kind of as good as it gets. Yeah.
Okay.
So
Could I ask a question?
yeah, please.
Could I ask a, do, so the room modes are dictated off the room dimensions and lengths because they're subdivisions of those lengths
Correct.
in to do with the waveform. Ignoring SBIR, just let's ignore that for the sake of
Exactly. Yeah.
this conversation. When I move the speakers into the speaker position, if it's let's say let's think axis, if it's exciting a particular room mode because they're all subdivisions of one another along a particular axis, will they all be excited equally? So along the x-axis, if that speaker's there, they're all excited equally because they're subdivisions and that's within the length of plane? Or does it only create differences in room mode excitement based on tangential and what's the other one? There's a third one,
Oblique.
oblique modes, because
Yeah.
they coincide multi-dimensionally.
Yeah. So they all get different energy, even the ones along the same axis.
Yes, okay.
Yeah. If you look at this plot again here, yeah, let's
Yep,
say you put your speaker kind of on the edge of this blue block.
yep, okay.
Yeah. For now, I go to the next axial mode, which is not that one. It's this one here. Yeah. Oh, it's a little hard to
Uh,
see, but the blue
I
block kind of is much narrower.
I
Yeah.
get what you're saying. Yep.
The
I
change in energy across the room is different, even though it's the
yep.
same. It's just a harmonic of the same axial mode.
Because it's subdivided across that. Okay, I get
Yeah.
that. That makes better sense. Yep, that's
Yeah.
very good to know. Okay, and
Yeah.
then yeah,
So
it's when you get to there, that third one, that it's actually sort of back in that position.
Yeah, yeah.
Okay, very good.
So this whole the reason I also recommend that you do set up your speakers and check that you're getting well, you're in the right listening spot and you're getting a decent low end.
Mm-hmm.
Um, Also, people underestimate how important the stereo image is. Yeah,
Yeah.
I'm a bit of a nut, and I always push this down people's throats because you can't mix without a proper stereo image. Yeah,
Mm.
people make this mistake that they do this whole procedure with just measurements,
Yep.
and then they completely ignore what the stereo field sounds like. And then
Mm-hmm.
sometimes they end up with speaker positions that are technically a stereo triangle, but they don't work properly. They don't build a proper soundstage because the speaker radiates differently. The room boundaries are actually narrower than, or are so narrow that the reflection pattern that then gives you all of it combined messes up the stereo sound field in a way that you're not getting a proper soundstage.
Yeah,
Yeah.
that's actually really good. Question.
Yeah.
Taking my speakers out of my current studio is a real pain in the ass. Can I use a
Yeah.
different speaker to measure from the corner?
Yeah. You can use a different speaker for the corner test, yeah,
Yep.
because you're using a measurement microphone and the response doesn't isn't psychoacoustically impacted. It's just
Okay,
acoustic.
perfect. It's
Yeah.
just this
While
listening position.
exactly, it's once you then actually set up your speakers, at that point you're interested in the psychoacoustic aspect of the speaker setup. Yeah.
Yep, yep.
Within the space you're actually in with the speakers that you're actually using.
Mm.
Yeah.
Okay,
Because they all
beautiful.
impact that soundstage and how your brain actually decodes what it's hearing. Yeah.
Nice. Okay,
Fortunately, at
that
that
makes
point, you do want to use your actual speakers. Yeah.
okay, perfect. All right, I might have to. That's going to be fun. I just don't like taking shit out of the studio.
I totally
Um,
get it.
I might have to do it over a weekend or something where I can take it one way and take it back.
Yeah,
Um,
it is very much worth it because again, everything else depends on your listening position and your speaker positions, yeah,
yeah,
including where the treatment goes and all this stuff.
yeah.
Yeah. And it's basically if you I don't want you put to get into a position where you've done all this work, you've done all the treatment, built all the scaffolding, put everything in there, stapled fabric on top, and then you realize your listening position isn't in the right spot.
I have a good solution for the fabric though. I don't staple it on to the frame.
Do you use those what are they called? Fabric,
No,
what are they called?
even cooler.
What are you
Um,
gonna do?
I hollow out sheets of MDF and then I hang them on the wall. Have you
What?
ever?
I'm not sure I
Yeah.
understand.
Okay. So you can get big
As
sheets
in,
of M.
you cut out the middle bit. Is that what you're saying?
Yeah, I cut out the middle bit. I leave a little section on the middle so it's got a bit more strength,
Okay.
so it doesn't
Yeah.
warp. And MDF's manufactured with perfect straight edges.
Uh-huh.
So when you wrap that in the fabric, you can hang that on the wall. And if you ever have to get behind the wall, you can literally just pop it straight off and
Interesting idea.
access every. And that was at the first studio I used to assist at. And it was amazing because whenever we had to access any cables or anything,
Yeah.
it literally pops off. And that's what I've got in my current studio. And again, you can hide doors in them as well. You can make doors out of
Sure.
MDF and put the hinges on the frame.
Exactly what I
So
was
that
just thinking.
way you can have like completely flush doors that look like a wall. And I put, kitchen cabinets that have the push pull
Hmm.
thing. Don't even need handles. They're all on push pull.
Awesome. That's a great idea. Yeah. Never
Yeah.
seen that before. Good idea. Yeah.
Yeah. No, it's a good. I saved my friend a lot of money on the truck system because he was getting quoted for it. And it was
Yeah.
something like,
Fabric truck. That's what I was thinking of. Exactly.
yeah.
It's super
And
expensive.
yeah, it's like in Australian dollars, it was like $30 a meter. And I'm like, dude, you can get a sheet of MDF for $50
Yeah.
and you've got many meters there and it finishes perfectly. You don't have to worry about as long as yeah, it's easy. And the trick to doing fabric, which I learned as well when I did my room, is get a long wooden broom handle,
Hmm.
staple the fabric to that, and
Okay.
then pull it with the broom handle so it all pulls
Hmm.
evenly, and you get a very straight pull before you
Oh yeah.
staple it onto the MDF. So I have no sag in my wall. They look all
That's a good idea
super.
too.
Yeah, that's all right. I'll
I
teach
know
you a
that.
few things in exchange.
Yeah, I know that the super high-end people, they actually hire proper what do you call the people who like who cover furniture? What are they called? Uh,
Upholsterers.
upholsters, exactly.
Yep.
Yeah,
No, don't.
because with all the creases and the potential corners and gaps and all that shit,
No,
making sure to hide it properly, it is hard.
it is
And
hard, but if you take time and patience, and you
yeah,
can you can, at least I've been very successful in doing it well.
nice. That sounds great. Good idea. Yeah.
Yeah. So,
Um,
back to it.
yeah.
Sorry to bore you with that.
No, 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 no. That's a great idea. Actually, this is some of the stuff that I'm really I'm really interested in. Like, I have a few different techniques that I kind of pass on to people that are potential solutions. But it's yeah, like I said, I know that the super high-end people actually just hire professional people to do this because it's the visual aspect. It's the one
Yeah.
thing that you see, and if it's not perfect, everything looks like shit, even though it might be acoustically really great, you know?
Yeah,
And
and you
so
don't want that. Yeah, but yeah, the
yeah,
broomstick trick is the best.
that's a good
You'll
idea.
never get a sag.
Nice. So yeah, that's pitfall number one. Okay.
Yep.
So the whole just figuring out what is actually going on with the low end, confirming that it's as leaky as you expect,
Hmm.
also confirming that your calculations for the room modes are correct, and then also using that information and testing the room to check out to really nail down your listening position, make sure it's in the spot that you want it to be, and also your stereo setup because that will confirm that your listening position and your potential speaker setup is going to work.
Yep.
Okay.
Okay, that's perfect.
Yeah. So that's kind of the first thing you want to double check because again, everything else depends on it.
Okay,
So
easy.
yeah, moving on. So now we're going to talk about treatment.
Yep.
Yeah. Let's assume that your room isn't as leaky as you expect, as in it's not perfectly leaky. It's not one, because it is not going to be 100% leaky.
No,
It's going to be
it,
like 50%.
100% leaky will be no walls.
Exactly. Exactly. And you also have to consider that if they leak through the drywall, they will eventually find another wall and then
And
reflect off.
bounce. Yep.
Yeah. So that is something that you might find that there are weird resonances, as in room modes in your measurements, and you have no idea how they pop up because they don't relate to your actual room dimensions. And it might
Hmm.
just be that the room mode builds up between some outer wall of the building and another
Yep.
outer wall of the building.
Yep.
Yeah.
No worries.
But that's the fun of home studios. Yeah.
First points.
So let's assume that the room isn't 100% leaky. Let's say 50%. And that
Hmm.
still means that the rumors, the those rumors are still going to get excited. They're still going to carry energy, but they're just
Hmm.
not going to be as strong. Yeah.
Okay. Yep.
So in amplitude, the frequencies aren't going to change. They're just not going to be as big in amplitude. That's basically what's
Hmm.
going to happen. Yeah.
Hmm.
They might, thinking about this now, they might also shift in frequency if any of your drywalls actually move. Yeah.
Ah, yeah, they won't
Yeah.
move
Okay. Good.
because
Yeah.
I smacked so many screws into the drywall when building the house.
Yeah.
I was very conscious of this, and yeah, they're peppered. They're peppered.
Okay.
So,
All right. That's good because what sometimes happens, and that's a typical thing with Windows, for example, as well,
yep.
and just yeah, large stretches that can move in
Warp.
themselves, is that they basically become resonant structures, and they don't just let sound through, but they actually reflect some of the sound, aka they still create that room mode, but it gets shifted in phase. So the actual wall that the sound sees isn't the drywall as an idea. It's basically behind it somewhere.
Yep.
Yeah, because there's a phase shift introduced through the resonance of the wall. Yeah,
Hmm.
what that does is it changes the frequency of the standing wave potentially. Yeah,
Hmm.
how does it change? Completely unpredictable. Yeah.
Yep.
But that's one of the issues that people run into when they're dealing with leaky walls, especially if they're constructed cheaply. Let's say it like that. Yeah.
Yep. Yep.
Anyway, moving on.
Yep.
So let's assume your low end still is kind of 50% of the amplitude remaining, yeah, in those
Hmm.
resonances. So you still want to stop them. Yeah. You still
Yep.
want to kind of do your best to stop them. Now, your plan, as far as I understand, you're planning a combination of some membrane absorbers.
Ooh, maybe you've got an old. No, no, no. I was originally going to put membrane absorbers in, but then I scrapped them.
Okay, good.
I scrapped them because the size of the space that I had to put them in, versus so it's not the room isn't it's not like I have lots of wall to put lots of absorption on or lots of wall to put lots of membrane on. So it's sort of like if I start putting up membranes that are big enough and effective enough to deal with these room modes, I'm trading it off for a lot of absorption space in lieu of it. So I was looking at it, I go, that's a bit like playing Russian roulette with those membranes because I'm going to lose a lot of potential um, broadband absorption. And if it doesn't work, I'm not getting that space back. So I go, you know what? I'm better off going broadband across them. If it was a much larger room, I probably would have pushed for membrane. But for this size room, I go, no, I'm not going to risk that.
Great. I would say that's a very wise decision. Yeah. Because
Mm.
the other part of it is, have you ever tried to build membrane absorbers?
No, but I wouldn't have a problem, I think.
So it's not the construction so much as
Yeah,
in the actual acoustical design. Yeah.
yeah.
So some of the pitfalls there, and that's why I was gonna put a big question mark behind that, but I'm glad you already made the decision not to do that. One of the pitfalls, or some of the pitfalls there, is just getting it to actually work at the right frequency,
Hmm.
and also just getting it to work. Yeah.
Yeah,
So the tuning and the actual effectiveness. So those two factors, tuning is a matter of getting the dimensions right of the box, the weight of the membrane. That part you had, I think you calculated somewhere you had right.
yep,
But then the actual kind of flexibility of the material plays a large
yep,
role.
yep,
Yeah, how you mount it plays a large role. So the
yep,
size of the box.
yep,
If you put insulation material inside, where you put the insulation material,
yep,
yeah, all those things impact the resonant frequency,
yep,
and that isn't properly reflected in any of the typical kind of calculators and calculations formulas
yep.
that are out. Yeah,
Even things like a modulus of elasticity with the actual membrane. So if you're using sheet metal, exactly different actual metals have different
that's right.
flexibilities. Yeah, no, I looked into all of that very deeply. Like I said, my knowledge with acoustics is pretty deep, and that's sometimes debilitating because my original plan had membranes and diffsorbers and all these things, and then I'm
Yeah,
looking at the space and I go, I've peppered this with all this technical stuff which is great. Like it's great to design and put that in theory, but I go, what's going to get me the furthest and be the most efficient design with low risk as well? Because those things aren't as much as I love building things. That this could turn into like a 1 month build. This could go from a 1 month build to a 6 month build, and it's like
exactly,
no. And then it's a 6 month
exactly,
build you could be fixing because I've had friends who have built studios that rip it apart and put new membranes in and change it and this, that, the other. And I'm like, no, I don't want to go down that rabbit hole.
exactly. Yeah. So well done on that. I think you identified the main, yeah, what do you call them? Trip up points, if you will. Yeah.
Yeah.
And that's exactly what people stumble over and then end up not finishing. Actually, designing it to work at the right frequency is what we've just talked about, but also figuring out what frequency to treat, which is the part we just talked about previously. Yeah. Figuring out
Yeah.
room mode frequencies and all that stuff. But even there are kind of pitfalls in how you measure. For example, the measurement resolution is an important factor. Yeah, if you're going down to 33 hertz, you better make sure that that resonant frequency is actually at 33 and not 35.
Yeah.
Yeah, because the absorption of those membranes is often very narrow. Yeah, and the resolution of measurements actually changes with the window that you're looking at in terms of in time. Yeah, and since you're trying to remove or just you're trying to remove any unusable data. You're trying to reduce the window of what you're looking at the actual usable data. That reduces the time period that you're looking at, which in turn reduces the resolution of your basically your frequency analysis. Yeah.
Mm.
So the measurement might end up showing 33 hertz, but in fact it's at 35.
Yeah.
Yeah. because the resolution is too low. Yeah, so that's it's just one of the many trickeries that you have to deal with when building resonance absorbers. There's also the fact that if you put a ton of boxes in your room, especially a room this size, you're reducing the volume and the size of the room to the extent that that will shift the frequency of those room modes.
Yeah. Yeah.
And then you put porous absorption in, and porous absorption also shifts the frequency of room modes. Yeah.
Yeah.
So you end up in this push-pull scenario where, without a ton of experience, you have no way of predicting reliably where things end up. And
Yeah.
so that's why you have to kind of count in or build in experimentation into your process in order to figure this stuff out. And people, you don't usually do that. And then kind of you build your first round and you back yourself into a corner, and then all you can do is rip it apart. Yeah.
Yeah.
So long story short, I'm glad you
Yeah.
decided to do
Yeah.
that.
Yeah. No, no, that's
Yeah,
good. For the size of the space, I'm happy to avoid
exactly.
it. Um,
Exactly.
yeah. So
Uh, yeah,
any other thoughts about the general sort of layout
yeah,
with yeah.
exactly. So let's move on to that. First of, so the next thing to consider is with porous absorption,
Yeah.
the general formula for identifying effectiveness is the absorption coefficient, aka how low down it's going to absorb,
Mm-hmm.
times how much surface area you're covering. That's
Okay.
So how much surface area are you covering in this with this absorption coefficient? Yeah.
Okay.
And
Yeah.
that determines your overall absorption. Yeah.
Yeah.
The first part of this, the absorption coefficient, is a question of depth.
Yep.
Yeah, right. And so I just want to make sure that that with the depth that you're aiming at with your absorbers that you're at planning with the room right now, low down you're actually going to get.
Yep. Yeah.
Yeah. Is this something you've considered
This
properly?
is something that will be in the documents where I've run some calculations. Let me just go back to preliminary assessment of room acoustics. I did have a document somewhere here. I can't find this document. I put them into what's that multi-layer. I think
Yeah.
it's one of those calculators
It's the same
as
with
I
them.
was planning. I got to go into my emails and find this because I emailed it to you, but it's not indexing on my
I
on
thought
my
I'd seen it as well, but I can't
yeah.
right now. It
Was
doesn't matter too much because you probably have a good idea of
project
uh,
homepage I had to go to. That's right. Project homepage. Okay. Is it called Studio Build Plans? I just got to search it in my Notion. Studio Build Plans. There we are. Blah, 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 blah. Material research. Because there's a bunch of documents here you can't see. Because I've even got my membrane trap plans and designs in here, but they're in a database, so they don't share on Notion for some reason. Treatment plan. Did I send you the treatment plan? Yeah. Those are for the membranes.
so I
Diffusion
got something
plan.
here. Are you looking at my screen as well, the share, or are you looking at something else?
Yeah, I'm looking at yours now.
Okay, yeah. So this stuff is kind of the important stuff right here, right?
Okay, yeah,
Yeah. And obviously this 117 hertz is quite high in frequency.
yeah. Yep.
Yeah. So if we did I just close the rock thing? Oh, I'm such an idiot. I think I did. Hang on. Let's see if I can. There we go. You go away.
Yeah,
So
this is what I used. I used the multi-layer one with that.
exactly. Yeah, you don't necessarily need the multi-layer one at this for this particular. So I'm just going to stick to this one.
Application. Yeah, that's all right.
Uh, so let's start with the lowest one, just to get an idea. Yeah.
Yeah,
Uh, of what's going on, of what we can expect. 33 hertz. Obviously, that's kind of down here somewhere.
yep,
Yeah. So I'm just going to use the second one. Uh, let's go for 220 centimeters, 10 centimeter air gap. I'm also going to put this on random incidence. Well, you have to look at both. But so now we're looking at a total depth of 30 centimeters. 20
Okay, yeah.
centimeters insulation material plus 10 centimeters of air on
Okay.
the wall. Yeah.
All
And
right.
with that, we're still kind of at like an absorption coefficient of like zero point 0.3
Which
at
is
33.
nothing.
Yeah,
Yeah.
which is basically negligible. Yeah.
Yeah.
It starts getting interesting. Let me just get the air gap at the same size. That's still not enough. Yeah, so now we're at like just over zero point 0.5. Yeah, this
Okay.
is where you're gonna start to see an effect.
Okay. What happens if it's just 600 and how does the gas flow resistivity change it? It's,
Okay.
yeah. Okay. Because I can
Yeah.
get, if you look at my material list, I can get gas flow resistivity of like 5,000, I think. Like
Yeah.
I can,
The material is gonna start being very sloppy at that point.
in what sense, sloppy?
As in it's gonna be difficult to actually just put it in the frame and keep it
Oh,
there.
that's easy. Oh, well, what
Yeah.
happens is with a lot of that insulation, because I've fitted out with the insulation, even the frame, and did a whole bunch even upstairs for the bedrooms. When
Okay.
you build out the frame to the standard centers, it's
Yeah.
manufactured at those centers, so it just sits right in snug. It doesn't
Even
fall.
if you pile it floor to ceiling and on top of each other, it doesn't sag down.
Yeah, even in the ceiling has like 210 mil bats, which is like 6,000 gas flow resistivity. But because the joists are
Hmm.
450 centers or 600 centers,
Hmm.
those bats just slot straight in and sit perfectly.
Okay. And they like the weight of the bats that's what I'm trying to say. Let's say you're fitting two of these on top of each other.
Yeah, but you got noggins. You got noggins
Okay.
you sit them on top of.
Okay, good. Excellent. In
Yeah,
that case, that's it's actually
yeah.
good to know, then that shouldn't be a problem. Yeah.
In material research, I can tell you exactly what I chose to use. So the gas flow resistivity of, let's go to my list. Sorry. Where's my material research? Oh, there it is. So it was, let's go back a second. So R 5.0 ceiling. So let's go to insulation, R 5.0. They got a gas flow resistivity of 4,500.
Okay, that's very low. Yeah, but cool. I mean, especially with these deep, as you can see here, with these deep, with these depths, you actually it's beneficial to go down that low. Yeah, as you can
Yeah.
see
I think the back wall is 400 mil though.
in your plan for your studio.
Yeah, correct. So
Okay.
what was, yeah. Not that I can't run these myself, but it's just curious to get your commentary on it.
Yeah.
Because that's almost identical to 300, 300.
Yeah.
Yeah,
So you're
interesting.
basically you're the reason I always do this half thing is because obviously
Yep.
you're saving a lot of material. Yeah. And
Yeah.
usually apart from, well, at these depths, it seems like, at least from the calculations, 400 fully filled is the same as half 600. Yeah. But usually at the shallower depths, you're not really losing much by
Yep.
doing half instead of the full depth. Yeah.
Yep.
And you're
Understood.
and there's also the mold thing, so you don't have to do the whole vapor barrier thing. And with people putting up panels, I'm just like, do the half thing. There's air. You shouldn't have a mold problem, and all those problems go out the window. Yeah, so that's kind of
Yeah.
why I tend to recommend that. Yeah.
Yep. No.
Obviously, as you can see now, yeah, and that's one of the limitations I just wanted to make you aware of. Yeah, with the
Yep.
plan as it's now, even with the 400, which is the deepest part on the back of the room, if that's correct.
Yep. Correct.
Yeah. So your ability to kind of touch that 333 hertz mode, you're gonna see a little improvement, but not much.
Yeah. No. Yeah.
Yeah.
Understood. Yeah. Very much
Yeah, so
understood.
that's that's kind of just getting an idea of what to expect. Yeah.
Yep. No.
Since it's also a game of how much surface area we're covering with this absorption coefficient,
Yeah.
things would change or would improve if you'd actually do the same thing on the front wall.
But I
Yeah.
got two windows there and I like my
Exactly.
windows. Yeah.
Yeah, exactly. Yeah, I'm just
But
saying this is how that would work. Yeah.
and then, but then the windows also have two problems. One, they're leaky, which can be a good thing, but then they're also resonant, which can be a bad thing. So
If if the windows are modern windows, double or triple glazed,
yeah,
you shouldn't have any problems with kind of reflections or resonances in the windows.
okay, perfect. They're double glazed. Yeah.
I tend to, for the sake of argument, I just tend to say from double glazed onwards, they basically behave like drywall.
Okay, perfect. That's good. I got
Yeah.
good drywall there then.
If you do this thing, the first step that we talked about, listening positions, setting up the speakers,
Yeah.
if the windows do something funky, this is where you'll find out.
Okay, perfect. That's good to know. That's
Yeah.
good to know. So
Again,
I
one of the
got that.
reasons why it's so important to do that first. Yeah.
Yeah. Yeah. And then we've also got, and then I put that diffuser at the back to prevent any sort of flutter echo in the
Yeah.
space.
Um, you can do that. It's probably going to be more of an aesthetic thing than an acoustics thing.
Okay. So you don't think it'll have much effect or impact on the sound?
If well, considering the alternative, which is to just put absorption there,
Yeah.
yeah, in that case you wouldn't get a flutter echo either.
Yeah.
Yeah. Um, you would get some additional surface area that actually does low end absorption for you.
Yeah.
Yeah. So there's kind of the in terms of pros and cons, I would lead or I would lean towards just making the entire thing absorptive because with the diffuser there, it's a rather small surface area you're covering. Yeah. So
Mm,
you're just breaking up reflections in on that box in that surface area of that box, basically.
mm,
Yeah. The main thing is that it's band limited because
yeah.
QRD diffusers basically what with a design like this is probably going to work upwards of I don't know 200 300 hertz up to maybe I don't know 4 kilohertz, let's just say for argument's sake. Yeah.
Yeah.
So it doesn't do anything low frequency wise, obviously. Yeah.
Yeah.
It's not going to do anything for standing waves. Um, and so you're basically using that space to do something band limited instead of using that space to do something broadband. Let's just say it like
Okay.
that. Yeah.
Yeah. Okay. Yeah.
It will
Interesting.
obviously break up any reflections, any energy hitting that area.
Mm-hmm.
It will return that energy to the room. So in a sense, it will contribute to keeping the room livelier in terms of
Mm-hmm.
feel. Yeah, but again, this is a surface game as much as anything. And since that QRD diffuser is in comparison to the rest of the or how much surface area is available, it's small. It's not going to do much in terms of making the room lively. Yeah.
Okay. Would that be something better than left at the front of the room if I were to put it at the front?
My experience is says no.
Okay,
Yeah,
fine. That's okay.
mainly because from what I've seen, speakers do not like reflective surfaces around them,
Okay, that's fine.
diffusers or otherwise. Yeah,
Yeah, no, that's fine. That's perfectly fine. Yeah. I think I will still keep it for aesthetics, not for anything.
what?
Just, yeah.
Absolutely. Feel free.
Yeah.
Um, here's another option. Obviously, you could do
Yep.
a slat structure on the back of the room as well. Yeah.
Yeah.
So at the moment, you've got that there on the sides, and
Yep.
it's equally spaced. Yeah.
Yep.
We could look at actually figuring out the right spacing to get some scattering happening off of that as well. Because at the moment they do some sort of scattering, but it's very, very limited. And you can kind of increase that by following a particular pattern, yeah,
Hmm.
and a particular slat pattern. And you could do the same on the back wall.
Interesting. Interesting. Very interesting. Okay.
Yeah.
Mm. Mm.
Again, and also because that then covers a much larger surface area, you'll actually get a much the change you will get in terms of perceived liveliness in the room is going to be greater as well.
Mm. Interesting.
The
Yes.
downside of these slats is they're even more range limited. in terms of the
Yeah.
scattering part of it, but obviously they let all the low end stuff through, which then gets absorbed behind. So you get kind of a
Mm.
combined absorber diffuser thing. Yeah.
Interesting. Yes. Yes.
Yeah. So something to consider. I don't think there's a right or wrong here. Yeah. Will it make any impact at all on the sound or on your mixing ability? None
No,
whatsoever.
no, no, no. That's not what I'm concerned. I'm,
Yeah.
I'm, my. So at the moment, I've already built the diffuser. So for me,
Okay.
in that mind, it's
Well, then might as
then it's
well.
going in. Yeah.
Yeah, it's going in.
Um, the rest of it is really interesting to listen to because I actually have a lot of flexibility with material choice and the data I have to
Mhm.
manipulate the walls to operate as I need
Mhm.
with broadband absorption, which is good. Um,
You could
yeah,
put
and
slats around the QID diffuser.
yeah,
Nothing's stopping you from doing that if you like the aesthetics.
no, no,
Yeah.
yeah. I'm just thinking, which is good. I did see an interesting design here in LA, which is much more complicated to build. It's still
Okay.
broadband absorption, but it's much more
Mhm.
complicated to build
In what sense?
because when I do frames, I can literally chop up all the lumber, smack it together with nails, lift it up, square it up, and
Mhm.
then smack it in. Very like the frame will take me a day to build.
Mhm.
I'm like, that's no stress.
Mhm.
I saw a studio where they had broadband absorbers, but it was almost like a whole wall, but they had reveals around them. So they were hanging on a cinder block wall. I'll show you a video, or maybe I
Yeah.
can get a picture.
Not
It's a bit
entirely
hard
sure
to.
what you mean.
I, the reason why I liked it is because let me just Google this is because it allowed the space to feel much bigger than what it actually was. Let me see if I can share this copy image address. Oh, come on. Can you give me a nicer photo? No, that's a bit annoying. Let me just scroll down till I find something now because I hate when studios take macro shots of their studio. It's like I can't see the whole space.
Can't see it.
Actually,
Can't
that's a
really
good
see.
one. Where are we? Chat. There we go. Actually, I can just share my screen. Send request.
Yeah,
Don't
please.
worry.
Not actually on Instagram.
Multiple presenters can share. Or can I share my screen now?
Yeah, I need to actually just set that up.
Oh, sorry, man.
Should-
Oh no, I'm not having a go at you. I thought I was managing the meeting, so I'm like, why isn't it let me do that? Okay.
Can you? Can you share your screen?
Yeah, I can do it now.
Okay, there we go. Yeah.
So if you see here, there's like
Uh-huh.
a reveal, but these are big boxes hanging on the wall.
I see. I've seen this before. Yeah, yeah, yeah.
And I like it because number one, it makes these boxes on the ground, which go around the whole studio, make it really easy for cable management. But
Mhm.
then you don't close in the whole room with a wall. You've got this light flying back onto the
Yeah.
wall, which actually gives a better sense of depth.
It does. It gives you a sense. Well, you still identify or feel that the room is actually the outer the outer walls, right? And
Exactly.
it's it feels makes the room feel very different. Yeah.
Yeah. So I'm debating whether I do that or not. But it is much more complex. Like it's doable and it's not difficult, but it just instead of it being a day to throw everything up, it might be 3 days to put everything
Sure.
up. Um,
Oh, my or one thing to consider is
yeah,
you're removing part of the surface area that is doing absorption by doing this. Yeah.
I
And
know,
obviously
I know.
sum that up across all your absorption. It's 15%, let's say. Yeah, it's not crazy amounts, but considering that your plan as it is right now is already limiting the amount of surface area that you're covering.
Yeah,
Yeah. Um, I would say see if you can get as much surface area in there as possible,
yeah.
which
No,
would
which would
mean
be
into the
not
frame.
doing this. Yeah, no, I agree. I agree. I just saw it and I go, wow, this is actually really a really smart idea. But maybe not for this build, maybe for another
It looks
build.
cool, that's for sure. Yeah.
Yeah, it looks cool. It's
Do
great
a
to
lot
be
with
in the
lighting, which
rooms.
is fun.
Yeah, it was great with the lighting and the room sounded pretty good, which is good. But yeah, it was just fun to look at, and I'm like, oh, okay,
Mhm.
cool. Anyway, we'll get back to it. Stop
Yeah.
share.
Um, so we just looked at the absorption coefficient, 33 hertz. That's the lowest axial mode, front to back. Yeah.
Yep.
You obviously have to consider the same for the axial mode left to right.
Yep.
Yeah. And so looking at it right now, I think what is that? 20 centimeters? How deep is the absorption that you got on your sides? 20?
210. Yeah, 210.
What do you mean by 210?
210.
210. Gotcha. Okay. So 21 centimeters on either side, right?
Yeah.
And so just to confirm, so we're looking at, yeah, so the lowest, let's just say, let's put our lowest effective frequency at the kind of zero point 0.5
Yeah.
absorption coefficient. Yeah, so that's kind of 75 hertz,
Yeah.
let's say. Yeah. So below that, it's not really going to do much. Yeah.
Yep.
And judging by the calculation, your lowest room mode left to right is 48 hertz.
Yeah.
Yeah. So just keep that in mind.
Mm-hmm.
The way it's designed, or you're planning it right now, you're probably not going to do much to damp the left to right room mode.
That first one, yeah.
First one. Yeah.
Yeah. That's interesting. And then
Same
yeah,
principle. Yeah. For the floor to ceiling, I'm not sure how deep that ceiling component is. Yeah, but it
I
looks
think
very
it's
similar.
yeah, I think it's 210
Yeah.
on the ceiling.
So
Or maybe it's slightly more, could be slightly more. Uh 210 or 240. One or the other. One or the other. I think I'm limited with that with the joist
mhm.
because I'm not going to start trimming bits of timber down, as in like splitting it. So I think it's 240 is a standard joist or 210. I can't remember, but whichever one it is, that's what it'll be for just
Yeah.
effectiveness sake when it comes to building.
So just keep that in mind. Yeah.
Yep.
That's how it is planned at the moment, and you can get a rough idea of how well that's going to work
Hmm.
for different components of the low end.
Yeah.
Yeah.
Yeah. Yeah. That's a good
Talking
idea.
placement of the treatment, obviously, I've already mentioned ideally when we're looking at the front to back part, you'd want to do some in the front. Not going to happen because of the windows.
Yeah.
Left to
There'll be
right, yeah,
yeah, oh,
is
you continue.
fine.
Yeah, sorry. Yeah, sorry, you continue. I was just going to jump in on the front. There is one broadband absorber in between the windows, which may
Okay,
or may
good.
not be on there. Yeah.
Yeah, I mean, the more the merrier, right?
Mhm.
Again, because it's a surface area question as well.
Yeah.
Same consideration for the left to right. That's about half of the room on either side. Yeah.
Hmm.
That's pretty deep. That's pretty good. Yeah. And then looking floor to ceiling, you're not really doing well. That box, that cloud, it, surface area wise, is only about a what is that? A quarter of the surface area of the ceiling, something like
Yeah.
that.
Yeah.
Yeah,
I'm
maybe
just
a bit.
going for that first reflection point with that.
So talking about that, the first reflection is going to happen, in my opinion, further forward.
Yep. Yep.
Right?
Again, the one, are you looking at the Notion board?
I'm looking at the SketchUp.
Okay. Interesting. Interesting. You reckon it's going to happen further up?
Yeah, because at the moment, I'm not sure how I can show this to you. Because at the moment, when we're looking at the stud work on the left and right,
Hmm.
you're covering the back half of that on the ceiling,
Okay.
right?
Okay. Yeah. So
And
you
so
reckon shift it forward?
I'd recommend you do the entire stretch right up to the front wall.
Ah, okay.
Two reasons. The first is the reflection, which is going to happen probably somewhere midpoint between your speakers and your listening position.
Hmm.
Yeah, because your speakers and listening position are going to be at the same height. Yeah, so that reflection point, thinking like playing pool, billiards, it's pretty much going to happen right in the center between those
Hmm.
spots, right?
Yeah.
But also speaker boundary interference, right? Speaker
Okay.
boundary interference isn't just something that happens on the front on the wall behind the speakers. It potentially happens on all the surfaces. Yeah,
Yep.
as long as they're close enough. And yeah, Let's just leave it at that. As long as they're kind of close enough. Let's just say within 2-3 meters or something. Yeah.
Mm.
So in your case, you're going to have speaker bound interference potentially pop up on the front wall where the window is, potentially on the side walls, and potentially on the ceiling. Obviously the floor, but we don't care about the floor because we're not going to do anything with the floor.
Mm. I never thought of doing the whole roof all the way
Yeah.
forward. I was trying to avoid it because I don't want to drop the ceiling so high that it makes it feel closed in.
Totally get it.
Um,
Yeah.
mm,
But so again, that's just a recommendation there, and you need to decide whether that's a compromise you want to make or not. Yeah.
mm.
If you don't want to do that, I would say at the very least, move the existing cloud. Let's say, well, I really would recommend that you have absorption right above the speakers. Yeah.
Yeah.
Um, that would basically mean that you move the entire cloud, shift it all the way to the front wall. So it covers the other half of your left to
Okay.
right stuff. Yeah.
At the moment, that drywall above it, there's drywall and then 210 mil of 4,500 gas flow resistivity insulation above
So that's your, yeah, it's the room structure.
the existing structure there.
Yeah.
That's what's
Yeah.
sitting above it.
Yeah.
Um, would you
That's
still
fine.
go? Yeah. Is
I mean,
is is
to me, I always separate out the kind of the isolation part, which is anything that happens as soon as you put up a solid barrier in front of it, aka
okay.
drywall. Right? At
Yep.
that point, this now becomes an isolating structure in the way I view things. Yeah,
Yep.
and that part is I see that separately from the actual treatment. Yeah.
Yep. Yep.
So I don't know if that's what you're kind of alluding to, but I wouldn't consider the drywall plus insulation material on top of it as contributing to the absorption in the room. Yeah. Obviously, there's going to be the leakage thing, but
Yep.
that's all we're going to consider.
Okay. All right. That's fair enough. Maybe I can do something interesting running the whole frame upwards. I've got an idea.
Yeah.
Yeah, I've got an idea.
One more thing to consider.
Yep. Continue. Sorry, man. I'm just
That's
I'm
fine.
just
No, no,
thinking
no.
as you're feeding in.
That's perfect. Make notes, ideally. I mean, obviously, you can watch the video again, but I mean, I just want to raise this with the shallower absorbers,
Yeah.
as in 200 millimeters or potentially even less, it might be worth looking at a higher gas flow resistance.
Okay. Why higher gas flow resistance?
Let me show you.
Okay, it's a bit more
Small
effective.
wins, small wins, but
Yeah.
yeah,
Yeah. Yeah.
probably doesn't make a big difference in the grand scheme of things.
Mm.
Yeah, but might as well. This becomes even more relevant once we're looking at even shallower depths. Yeah, so if you do end up making something even shallower, well,
Mm.
to be frank, not that much. Yeah,
Yeah.
it's just worth considering. Yeah.
Yeah. Yeah.
Basically, the shallower the absorber is, the higher the gas flow resistance up to a certain point. I don't really recommend you go anywhere beyond kind of 10,000. Yeah. Because
Yeah.
at that point, what starts happening is the material actually starts getting reflective in the top end. And
Yeah.
that's something that these models don't show.
Yeah.
Yeah. But yeah, might as well avoid it. Yeah. Because usually what you want to do is have the outermost layer as close as possible to the impedance of air so that air enters really easily. Yeah, so
Yeah.
that's why we also go for lower gas flow resistance on the top of the absorber, ideally. Yeah.
Easy.
Anyway, so we've covered that. Yeah. So considering the depth and what range of frequencies you're actually going to potentially hit, low
Yeah.
frequencies in particular. Yeah.
Yeah.
Talking about the back wall, left, right wall, and then also the cloud. Yeah.
Mm-hmm.
And then the size of the cloud, just to make sure that you have some absorption above the speakers and where the mirror point reflection will probably happen. Yeah,
Yeah. That's going to be fun. That's going to actually make it easier to build. That's good.
great.
Well, because uh, when when I built my last room, um, I screwed in two big beams to the existing structure along the side, and
Hmm.
then you put U brackets with the joists. Then you
Hmm.
run your joists across.
Hmm.
The beauty of that is when you have to put your frame up, you literally build it on the ground, you hold it up with a square level, and then you just start smacking nails into the joists where it meets. You don't have to use stud finders or anything. It just all goes up really fast. Whereas in the design where I only have the joists in one section, um, I've only got that small part where it's easy to do, and then the rest it's not hard. It's just use a stud finder, but it's just easier
Yeah,
having the
makes
joists there.
life makes the job easier, makes it quicker.
And
I'm all for
also knowing I don't have to, I know I've got a three-phase cable running across that ceiling as well, which would be horrible to smack a nail into. So if I have the joists there, it'll mean that I can just I can go a little bit crazy with not crazy, but I don't have to be stressed about smacking a nail into my subboard's power supply.
Perfect.
Yeah, cool,
Yeah.
cool.
So those
That's
those that's kind of the gist of it. Yeah. There's a bunch of other details I could still pass on, but those are kind of the important bits. Yeah. So now you have an idea, first of all, how important the listening position is, yeah, and what
hmm
impact that has. Um, Understanding how large or how leaky the room actually is, yeah, and
hmm
how that's going to potentially impact your listening position, yeah, and then
hmm
obviously the position of the speakers, and then just getting a feel for how much your current plan is actually going to absorb sound, in particular low frequencies, and how much control you can potentially expect. Yeah,
Okay,
yeah.
perfect.
So
So
it's a good plan. It has some limitations, and that's totally fine because that's the room that you're dealing with. Yeah.
yeah, lovely. So then to wrap up, my goals will be get a speaker into the corner, make measurements on the opposite corner to see how much of that lines up with what I've calculated in room mode calculators. Then do actually with my actual speakers, figure out the listening position, speaker position to see how far it moves or excites room modes until I can get into a spot. Um, Finalize material selection for the absorption because I didn't send you the PDF. There's actually the test sheet which I can send you for that material if ever you work with anybody in Australia. Um, so that way I've solidified and decided the material for the installation based on the tests I do in there. So it's just sort of check summing. I don't think there'd be much variance because I'm limited with material and the room modes aren't going to deviate. Well, they will deviate, but they can't deviate a whole octave out or whatnot because that's
Probably not. Yeah.
yeah,
My
that very much.
my suspicion is that the room isn't as leaky as you'd expect.
I don't think it's as leaky as I expect either.
Okay.
The doors. I got to put another door on there, like a two-door communication door, because I want to put a mechanical drop down on the outside door just to stop speaking noise from getting in.
Hmm.
So anyway, going back to it, corner, speaker listening position. From that data, make sure I confirm I've got the right insulation for the project. Um, and the ceiling put all the way to the front of the room.
If not cover
Um,
the entire stretch.
I'm not covering the entire stretch.
Okay.
I'm not
Go
covering
for
the
two
entire.
thirds. Two thirds.
That will be two-thirds. At the door, it'll be two-thirds because
Okay.
it's past the midpoint. So you've got two-thirds there.
I would say as a rule of thumb, from the front wall all the way to above your listening position.
Yeah, it'll be slightly behind my it'll be
Perfect.
behind my listening position.
Then
Perfect.
you're safe.
Good. So that's going to be fun work. I think the total expense of what I've changed is maybe $200 or $300 in lumber, and that's
Hmm.
it. That's just to finish off the ceiling. And insulation for that is a bag or two bags worth, which is nothing. That's good. That's good. Awesome. Well, that's a good
Yeah.
call. That's a
I'm
good
glad.
call. I'm
Consider
gonna,
the slats on the back wall.
yeah,
One, yeah. Unless you already made a decision while we were talking. In that case,
yeah,
don't.
yeah. The slats I'll have to decide because I've got this.
By the
The
way,
slats,
it's this kind of pattern. Where's my
yeah,
finger? Right?
I
This,
seen, yeah.
yeah. And
Um,
then just imagine that stretched out across the entire thing.
yeah, yeah. I've got the slats on the two sidewalls. The back
Could
wall,
do the same on the sidewalls.
yeah. I could always retrofit that though. That's really
That's
good.
also true. Yeah.
No, well, for me, it's about being open and open to the critique and open to listening and learning. And even though the slat thing, I know you're pushing. It's again, I take on some things. I try and pull and push and pull.
No
The
worries at
fronts,
all.
the ceiling to the front of the room, as much as I don't want to, I see that it's sort of a necessary thing. I
Sure.
really don't want to, but I probably will now. But I just don't. It's like I get it. I get
I
it.
mean, I'm always like, I always say, like, feel free, do what you want, as long as you know what compromises you're making,
Yeah, I
right?
know the compromises I'm making, but that's one compromise I don't want to make. I
Okay,
mean,
there you
that's a
go.
compromise I want to make. Sorry, that's a compromise I'm willing to make because the effectiveness of that solution is really large in comparison to, let's say, the slats. Not saying
Yeah,
the slats are bad, but the slats is a minute improvement where I'm like, okay, I can always put that on after, I can think about it. Whereas the ceiling is sort of something like, okay, well, once it's up and it makes a great deal of improvement to the overall
absolutely.
design. So I need a compromise on that,
Absolutely.
um, despite not wanting to.